We are going to finish with chapter 10. So we will cover 10.1 today, and then we'll do 10.2 next week. Chapter 10 is all about working with data. So we'll talk about how we can graph different types of data. And then next week we'll do like mean, median, and mode. We will talk about bar graphs, broken line graphs, pie charts, basically to give us visual representations or interpretations of our data. We know that we can see data everywhere. You go on a computer, you go to the TV, if you happen to see a newspaper or magazine, you're going to see graphs in life. Basically, you want to be able to interpret the graphs appropriately, be able to understand what is being shown to you, and also be able to look at them and determine, is it in fact an accurate graph? Bar graphs are clearly easy to construct and interpret. What we do is we have different categories of data that are on the bottom or the x-axis, and then the count or the frequency goes up the y-axis. So depending on how tall your bar is how how many people have responded to that answer. An example would be, we could graph the US public debt, which is in billions here, for 10-year chunks. So in 1975, we have the value, 1985, we have a value, 1995, 2005, and 2015. And basically, it's just going to show how they compare or how things change over time. This is a bar graph here. So our years are on the x-axis. And then however tall they are corresponds to how much debt there is. And you can see that by looking at this, it pretty much across the board looks like it's doubling every 10 years, if not more than that. Just remember, with bar graphs, there are spaces between the bars. What we are working with is disjoint data, discrete data. We are not going to have bars touching in a bar graph. That is a separate graph called a histogram. So if you are ever asked to make a bar graph, please keep your bars separated. I trust everybody's seen a bar graph before, so I'm not going to spend a whole lot of time on it. If we wanted to create a bar graph here, I could do that. So I've got Atlanta, Chicago, LA, Dallas, and New York. And then I look at my numbers here. My highest number is 49.3. So I'm going to go up to, I'm going to count by tens to 50. So 10, 20, 30, 40, 50. To make an accurate bar graph, you should always start at 0, and then go at equal increments all the way up. That is why you have to make sure you look at your overall values, figure out what your highest one is, and then go a little bit above that so you can have a nice even scale here. And then you're just going to draw the bars as best as you can to where those values fall. So 27 is going to be about there. 31.6 is a little above 30. 36.3, about halfway between there. 36.4 should be about the same. And then 49.3 is almost all the way up to 50. All right, this one, drew it. I'll remove mine here so you can see it. Drew it as a horizontal bar graph instead of a vertical bar graph, and that is fine. You can always flip-flop and draw your bars horizontally. You'll see they also counted by 10, and it looks like ours just turned on its side. You may also see double bar graphs, and those are used when you want to graph and compare two different groups' responses. So this graph shows how many males and females there are compared to, their annual income, median annual income for male and female based on their degree. So if you have a bachelor's degree, you can see where the female average earns and where the male average earns. And associate's degree, you can see where the females earn on average and where the males earn on average. Average being in terms of median average, not mean average. And this can be done with all sorts of things. You could compare two countries. You could compare 2 different years and different responses. So maybe it was how many people had a bachelor's degree back in 1960 and now in 2020. So comparison graphs there. Another type of bar graph here, this one's called, sometimes it's called a stacked, our book calls it a divided bar graph, but sometimes it's called a stacked bar graph. And this one here is talking about population and where they're projecting that population to be. So the blue bar is what is current as of 2016. And then what they did was they predicted or projected where they think it's going to be. So then they added this red box of how much they think it's going to grow in the future. Next one is a broken line graph. In this, basically what you're doing is taking where you would have graphed your bar height to and instead putting a dot on the graph, and then you connect the dots with lines. And it's going to be kind of jagged. You're going to see how it kind of goes up and down. It's not going to be a smooth line, but it's going to be just connect each 2 consecutive points then with a line. It's going to graph the same information, just in a slightly different way. Another example of a broken line graph here is graphing revenues and costs. We learned very early on in class that your profit is based off of your revenue and your costs. And if your revenue is greater than your cost, you have a profit. If your revenue is less than your costs, you have a loss. So you can see how this graph, anytime the blue is over the red, we have a profit. And that happens here and here. And in the middle, we had a flip time where we were losing money. Our costs were more than the revenue. Another type of broken line graph here is if you want to graph multiple different things. So energy consumption, we have petroleum, coal, natural gas, renewable energy, nuclear energy, and you can see how that consumption has occurred and where they're projecting it to be in, say, 2030. Next one's a pie graph. A pie graph is generally used to show percentages based on a whole, and we are going to divide a circle into different categories based on how much of the sample answered a specific way. So think about segments of a pie, percentage of a pie, proportion of a pie. Going to give us the percentage of each category. You can do pie graphs in lots of different ways. You can put them in a specific order. You can order them in size. You can make them random. It really doesn't matter. It's just that each pie section should fall in its correct dimensions to the population that it represents. Here is a pie graph showing active U.S. military in the year 2017. The larger the pie section, the larger the percentage. You can see in this one that it gives you both the percentage as well as the degree of a circle. So a circle is 360 degrees. So a quarter of that is 90. And then that's how they got the other ones there. 36% of 360 is 130 degrees, and 14% of 360 is 50 degrees. Another graph there, just talking about the world refugees in 2015. Again, very quick, easy way to look at and figure out where the largest, smallest, how they compare to each other. We can use things like Excel or StatCrunch, if you did that in statistics, to help us create all of these graphs together. All you have to do is enter your information into said spreadsheet software and then select the correct graph that you want to make. So this is one that was made in Excel. Using the same data, I turned it into a pie graph. Let's say we want to make some graphs. All right, we could use Excel. You could go and use any other software you want to that you're comfortable with. You could honestly just Google line graph maker and see what it comes up with. So, for example, this was the first one that popped up here. I could say horizontal axis is month, vertical axis is percent of weddings, linear scale. So then I can just type all my months: January, February, March, April, May, June, July, August, September, October, November, December. And then my values: 4.7, 7, 6.1, 7.4, 9.8, 10.8, 9.7, 10.2, 9.6, 9.4, 7.4, and 7.8. And there's my graph. It shows how it changes over time. If you've used Excel before, you want to use Excel, use Excel. If you want to draw it by hand, draw it by hand. If you have another software or something you're comfortable with, feel free to use that when you create a graph. Next one wants us to make a bar graph. So let's say I decide to use Excel for this. I'm going to type my data quick here. Chem engineer on a separate screen just so I can see my values. Petroleum engineer, computer, just do that. Nuclear, aerospace, electrical, and just seeing manager. I'm going to enter my numbers: 64800, 3000, 58200, 63900, 59400, 60800, 58. All right. For Excel, you're just going to highlight what you got. And then I want to insert. There they are. Bar graph. So I could select that one. I select just a normal 2D bar, and it'll make my graph for me. Again, you can use this. You can use something on Google or draw by hand. You also have your option here, like you could change the style of the graph. That's not really the best style. You want to actually have a y-axis, but you can adjust your options up here. That one's kind of nice. All right, if you want to make a double bar graph, back here, I'll just make a new sheet, make it easier. So we have carbs, protein, fat, 375, 60, 100, 275, 44, 73. See if I can. It's gonna let me. So I could insert. I could go to a bar graph. When I want a cluster or a side by side. So then it's going to separate there. Here's your first one goes to 375. The second one goes to 275. And then you do have the option to edit those and say like, this was male, this was female. I just didn't put my labels in here, so it didn't put them there. But you do have the options to change those. Again, or just draw them by hand. Anytime we talk about numeric data, though, we can also graph things on a scale. And that's going to lead us into things like a whole bunch of scores like this, where it doesn't make sense to graph individual scores. So then we go into what is called a histogram. So this has 100 entrance exam scores, and we are going to group them together in order to make the data more useful, more understandable. So the first thing you generally do is create what's called a frequency table, and that's where you're going to decide how big do you want each chunk to be, and then count how many go in each group. So generally ways you can do that is find your largest and smallest value and then determine how many groups you want, and then you can divide from there. So our largest item was 787. The smallest was 340. So that's a spread of 447. Maybe I want to break it into groups of 50. So I could go like 300 to 350, or sorry, 300 to 349. And then it would be 350 to 399, 400 to 449, so on and so forth. Right? Exactly what they did there. 300 to 350, 350 to 400. Now, this is why I kind of wrote mine the way I did. What happens is this middle value here can only be counted in one of the two categories. So another thing that we can do, rather than saying like what I did back here was 300 to 349, those are the scores that are going to be in that first grouping. What they do is they add like a half. So instead of being, or drop everything back a half. So like, you want the scores the way I wrote it in the first category, 300 to 349. We want those scores to be in the first group. We want 350 to start the next group. So you can cut everything back by a half. So 299.5 to 349.5 would account for all of those scores. And then 349.5 to 399.5 takes that 350 to the 399, so on and so forth. So this book has us shift it back by a half. We know that when we did in elementary statistics, the way they created the histogram was we kept the whole number, and we knew that when we graphed on our histogram and it was say 300, 350, 400, when we did it like that, we knew that this first group, you always included the left number and you didn't include the right number. So this value was counted in the next grouping. It's all preference in how you're making things. Our book likes to do it like this, just to help clarify where any value that's quote unquote shared, it actually goes. So here they created the frequency table. They listed all of our ranges and then just started counting, putting tick marks, and then added up all those tick marks to give us our total frequency out of 100. And then relative frequency would be the percentages of the total as well. And then from there, you basically create your graph, and it's literally going to look like this, flipped on its side. So this would be grown to 1, 2, this would be a height of 5, this one's going to be a height of 10, this one's going to be a height of 21. It's literally going to make this graph rotated. So see how it turns? Your graph's going to look like that. Histograms are not going to have spaces between the bars because we are working with spreads of data, and where one group ends, the next group picks up. Frequencies are always going to be on the vertical axis. So here's another example of that. If you create a frequency graph or a relative frequency graph, they are going to look identical. It's just that the numbers are going to be different. One is going to have the whole counts. The other is going to have the percentage count. Because this one's out of 100, they correlate very nicely. We want to create a histogram. I'm not a big fan of using Excel. It's not as easy to work with. So I generally draw these ones by myself. So width of 10 starting at 120.5. So 120.5 is going to go to 130.5. 130.5 to 140.5. So they're going to tell you your width is how far apart your start and end values are. 140.5 to 150.5. 50.5 to 160.5. I got to go to 180. 160.5 to 170.5. 170.5 to 180.5. 180 is my highest value. And then I just start tallying. So 150 is going to fall there. 140 is going to fall there. 50, 125, 80, 40, 135, 145, 155, 160, 125, 170, 160 is that one, 145, another 145, 170 is going to go there, 165, 140, and then two 150s. So then on the bottom, I put my 120.5, 130.5, 140.5, 50.5, so on, all the way over. And then the highest count I need is 7. Okay, so the first bar is 2. Then there's 4. And then there's 7. And then there's 3. 3, 1. I think this is the last graph we do. Frequency polygons. So basically, it's going to look like a broken line graph on top of a histogram. So if you have a histogram, what you do is you find the middle of the bars, and then you connect all of those together, and it creates what's called a frequency polygon. You don't have to draw the histogram first. The key is that your dot is going to go in the exact middle of your spread of values. So if you had your spread of values of you could keep them as your spread of values, like 299.5 to 349.5. You could keep that there and then just put the dot in the exact middle. Or what they did was they calculated the exact middle of these was 274.5. So that's where my first dot was going to go. 324.5 was the exact middle of the second group. And then they did that all the way through. Again, you can graph frequency or relative frequency. It's not going to change the shape of the graph. It just changes the numbers on the vertical axis. The last type of one is called a cumulative frequency. So what happens is you're continuously adding to what you've already counted for. So if you have 1 in the first group, your cumulative frequency is 1. And the next group is 2 individuals, which you add to the 1 previous. So now I'm up to a total of 3. And it's going to keep counting the total. So you're going to see how you get up to that total group and see how it changes from there. So it's going to look, again, kind of like that jagged line. But it's going to now show how I get to 100%. So if at any point in time I want to figure out where a certain percentage is, all I have to do is find that on my axis and then go down. So like this value here is going to be the 60% value. So 60% of my data has occurred by the time I get to 599.5. And ogive, depending on how you want to say it, is another way to call this graph. Basically, it just helps. I can figure out like what percent is this score at, or what score is at this percent. I can answer questions like that. So 78%, they drew that one there, drew it down. 78% of the students score below 649.5. That means the remaining 22% would be above that. All right. Your homework for this is pretty much just like making graphs, draw the graphs. So there are 1, 2, 3, 4, 5 questions from the section. So the first one has you create your frequency table and then determine your relative frequency and then make a histogram. There's one here with which one's the correct bar graph, which one's the correct broken line graph. Remember, if you ever need to like see it bigger, you can always zoom in, or I think this one also makes it much larger to compare your values. Yes, that's fine. You're going to make a broken line graph and then talk about how you make a broken line graph, and then a side-by-side bar graph. So most of these are just matching. Can you find the correct graph from the data?